This is Mr. McGovern, and welcome to Level 3 Physics, Electricity, Internal Resistance. So I'm on a site here, PHET website, which builds little simulations of circuits. So I've got a battery and a light bulb and a switch. I turn the switch on and the light bulb glows. I can show electrons flowing around it as well, so it gives me an indication of the current, how fast the current's going. What I want to look at is the voltage. So I've got my voltmeter here. I'm going to turn it off. And I'm just going to measure the voltage of the battery. It gives me 9 volts. Okay, it's a nice easy number. But look what happens when I turn the circuit on. The voltage drops down to 7.5 volts. So what's going on here? Let's just check. What's the voltage over the light bulb? It also measures 7.5 volts. So I'll turn it off again. Back to 9. All right, so let's explore this further. Let's see what happens when we put 2 light bulbs in the circuit. Here I've got 2. I'll turn it on, and we get 2 light bulbs. So I grab my voltmeter and measure away. Turn it off again. So this battery, 9 again. Turn it on, down to 8.8. So that's different than our first circuit. Our first circuit had, when we turned it on, it goes down to 7.5. And our second circuit, when we put something else in the circuit, it changes what the voltage of the battery is, 8.18. So it has something to do with what's in the circuit. So let's just try something different. Let's put some more things in a circuit. This time we've got a circuit. We've got 2 bulbs again, 2 identical bulbs, but they're in parallel. So in this circuit, we go from 9 down to 6.43. So once again, that's different again. The battery is behaving differently depending on what's in the circuit. Now we know something about that already. We know that usually the other thing that behaves differently when something's in a circuit is the current. And the current depends on what's in the circuit. In other words, the resistance. In this case, it's very, very similar. We've got a battery that changes its voltage depending on what's in the circuit. The overall equation for what we can measure over the battery is V battery. It's equal to this thing here, which we'll explain in a minute, minus what's in the circuit. So the voltage of the battery is given by, this is called the EMF, and this is, I guess you could say, the proper voltage. In this case, it was 9 volts. Subtract how much current's flowing in the circuit. So this is the total current in the circuit. And multiply that by the internal resistance. This is a new concept. What this says is, that the battery itself has some sort of resistance. When we look at a series circuit, and we look at the voltage across each light bulb, 4.1 basically, 4.1 across the second one as well. 4.1 and 4.1 is the 8.2 total. Voltage gets shared in the series circuit. You can think of this internal resistance as there's almost another little light bulb in that battery. There's some component in the battery which has resistance. It's making it harder for electrons to flow. Some of the electrons are losing their energy in the battery, effectively. It depends on what's in the circuit, because if other bulbs are in the circuit, will affect how much current's flowing. How much current's flowing depends on how much voltage is going to be lost in this battery itself. So this resistance within the battery we call internal resistance. EMF is the proper voltage. I times R, we know from another formula, V equals IR. So this is measured in volts. This together is measured in volts as well, and this gives us our voltage of the battery.